If you have any confusion on the difference between pure substances and mixtures, I'll give a quick definition of both, and then I'll provide some examples on the next page. Pure substances are uniform. They are made of one substance. And they have a constant chemical composition. Pure substances can be broken into two categories: elements and compounds. Elements cannot be broken down. Whereas compounds can be broken down, but they can only be broken down chemically. Elements are what we see on our periodic table, like copper or oxygen. Compounds are molecules that we see in a constant ratio. For example, water. We always see 2 hydrogens and 1 oxygen. For mixtures, it's made of 2 or more substances. Okay? And it has no fixed chemical composition. Unlike compounds, mixtures can be physically separated. And mixtures can be broken down into 2 categories: homogeneous and heterogeneous. Homogeneous mixtures look uniform. And examples of a homogeneous mixture would be sugar in water. Sugar water can still be physically separated into sugar and water through a process of evaporation, but it looks uniform like one substance. A heterogeneous mixture, on the other hand, it is not uniform. You can usually see the different layers that can be physically separated, like a pizza, for example. You can physically see that there is pepperoni versus cheese, and you can separate the sauce from the dough. This is a quick overview of pure substances versus mixtures. Let's jump into some examples. The first example I have here is a brick of gold. This is a pure substance and an element. The only atom present here is gold. Salt in water. This is a mixture, and it's homogeneous. This is very similar to the sugar water example, where you can actually separate the salt from the water through evaporation, but it looks like a uniform substance. Methane. This is a pure substance, a compound. You will always see methane in this ratio. Oil in water. Oil and water is a mixture. When you mix oil and water, you get this very clear division line due to their densities. This means it's a heterogeneous mixture. A salad. A salad is a mixture. And again, like the pizza example, it's heterogeneous, as you can physically separate the lettuce and the chicken or whatever else is in that salad. Hydrogen gas. This is a pure substance and it's an element. There's only one atom making up hydrogen gas. Glucose, also a pure substance, and this is a compound. Glucose is always seen in this ratio. Air. Air is a mixture because we have nitrogen, oxygen, carbon dioxide, etc., but it looks uniform, homogeneous. Brass. Brass is also a mixture, and it is also homogeneous. You cannot see the separated parts of brass. Okay, ice and soda. This one is a mixture, but you can physically see the solid ice separated in the liquid soda, making it heterogeneous. I hope this video cleared up the concept of pure substances versus mixtures.